So this is part 2 for acid-base disturbances. This is a little bit lower yield. We're going to go in-depth into acid-base disturbances. We're going to talk a lot about how you approach problems, and also we're going to talk about how we deal with concomitant acid-base disturbances. That means you have multiple acid-base disturbances going on at the same time, which I mentioned that can happen. You can have a respiratory alkalosis and a metabolic acidosis. You can have metabolic acidosis and a metabolic alkalosis going on at the same time. So the question is, how do you figure that out? And we're going to talk about that here. So first of all, how do we approach these problems? They're going to tell you about a patient. They're going to tell you the pH. They're going to give you pH. They're going to give you a bunch of electrolytes. They're going to give you their CO2 values, their O2 values. How do you approach this? How do you know what's going on? So they're going to tell you CO2. They're going to tell you O2. They're going to tell you electrolytes. And from there, you're going to have to figure things out. So the very first question you're going to ask is this an acidosis or is it an alkalosis? Okay, and how do we figure that out? Remember, this is a super basic question. You just look at the pH, and that tells you whether it's acidosis or alkalosis. Now, the second thing, once you figure that out, is what is the second thing to figure out? The second thing to figure out is whether this is a respiratory problem or if it's a metabolic problem. And how do we figure that out? Remember, we look at the CO2 and look at it in relation to the pH. Remember that if the CO2 for respiratory, what would you see? Remember, in a respiratory problem, you would see that the CO2 goes in the opposite direction as the pH. For example, CO2, let me write opposite. For example, if you have a respiratory acidosis, that means pH is low. If the CO2, then the CO2 would be increased. Okay. So if you have increased CO2 and decreased pH, they're opposite. So you know it's a respiratory problem because it's opposite, and you know the pH is low, so you know it's an acidosis, so it's a respiratory acidosis. And a metabolic problem, CO2, same direction. Okay. So if you have an increased CO2 and an increased pH, you know, first of all, they're in the same direction, so it's a metabolic problem, and your pH is increased, so you know that's a metabolic alkalosis. So very easy. So next, now if we know that we have a respiratory problem, the next question is, the next thing you want to know is it acute or is it chronic? And remember, how do we delineate that? Well, chronic is pretty much greater than 3 days, and acute is less than 3 days. And why do we want to know that? Remember that metabolic compensation for respiratory problems takes time. So if your patient shows up with, I don't know, a COPD exacerbation, he's breathing really fast, he's hyperventilating, you want to know whether he's been hyperventilating for 3 days or for 1 day if he's showing up the first day. Because if he's showing up on the first day, what would you expect his bicarb to be? You would expect it to be normal because during that first day, he hasn't had time to have that renal compensation for that renal getting rid of bicarb to lower his pH. He's hyperventilating, he's blowing off all his CO2, he has a respiratory alkalosis. If he's been hyperventilating for like 4 days, he's had this problem for 4 days, he's been blowing off all his CO2, his kidney is going to have time to compensate. It's gonna get rid of more bicarb to lower the pH, and then so you're gonna get tested on this. You can get tested on this. They're going to tell you the problem. They're going to tell you this guy has showed up with a COPD exacerbation. He's breathing for a long time. It's been 4 days since it's been happening. And they're going to ask you, what is his pH? What is his CO2? What is his bicarb going to be? And you want to know whether it's acute or chronic so you can figure out whether the bicarb will be normal here or if it's going to be compensated. And in this case, it would be decreased. So that's why you want to know acute versus chronic. Now, if you have a metabolic problem, remember that you can acid and you have alk. If you have an acidosis, the next thing you have to figure out, what is the next thing to figure out here? The next thing to figure out is you have to calculate the anion gap. Increased anion gap, or if it's a normal anion gap. Remember, what is the normal anion gap? What's the number that you want to know? Normal anion gap is less than 12. If you have greater than 12 anion gap, it's an increased anion gap metabolic acidosis. Remember, anion gap is, how do we calculate that? It's sodium minus chloride minus bicarb. Okay? Now, if you have we just talked about compensation for respiratory. Now we're going to talk about how do we figure out if you have appropriate respiratory compensation in a metabolic problem. How do we know if this patient has compensated correctly respiratorily? For metabolic acidosis, for both anion gap and normal anion gap, you have something called Winter's formula. Okay. And what is Winter's formula? You might have been taught this already, but CO2 should equal 1.5 times bicarb plus 8 plus or minus 2. Okay. Let me give you a quick example. This patient has a pH of 7.12, CO2 of 18, bicarb is 6. Okay, so you know it's an acidosis. Remember, is it metabolic or respiratory? Remember, you see here the CO2 is down, pH is down, so it's metabolic acidosis. So now we can use Winter's formula to see if there's appropriate respiratory compensation. And we're going to use Winter's formula for this because it's a metabolic acidosis. So CO2, 8. So we're going to take bicarb, 1.5 times bicarb plus 8 plus or minus 2. So equals to 9 plus 8 plus or minus 2 equals to 17 plus or minus 2. This should equal to CO2. I told you that CO2 here is 18, so that is correct. So we do have appropriate respiratory compensation, and that we figured that out thanks to our Winter's formula. Now, that's for metabolic acidosis. Now, for metabolic alkalosis, it's a little harder. There's no specific formula here. But if you have a metabolic alkalosis, how should you compensate respiratorily? How will CO2 change? Well, normally CO2 should increase, right? Compensation will be CO2 increase. But in general, CO2 does not rise over 50. So your CO2 should be between 40 and 50, okay? Because if just for some reason, your body just doesn't do it. It doesn't go above 50. But you know that your CO2 shouldn't be below 40. It should only go up because that's how you would normally compensate for a metabolic alkalosis. So if your CO2, this is normal. This is normal compensation. If your CO2 is less than 40, what does that mean? You have a metabolic alkalosis, but your CO2 is less than 40. What happened? That means that you have a concomitant respiratory alkalosis. Because respiratory alkalosis you get from blowing off too much CO2. So that's the only reason why you would have a metabolic alkalosis and a CO2 less than 40. It's because you also have a respiratory alkalosis going on. Okay? If your CO2 is greater than 40, is greater than 50, then you know the concomitant respiratory acidosis. That means you're retaining too much CO2. Otherwise, you wouldn't compensate by going over these two numbers, okay? So that's how you can figure out whether it's appropriate respiratory compensation for alkalosis. Now, final thing. If you have an anion gap, so now we're going to focus in on this one. If you have an anion gap metabolic acidosis, we have another thing to figure out to see. We want to see if there's another metabolic disturbance. We used Winter's formula, and we used this CO2 between 40 and 50 to find out whether there's if there's appropriate respiratory compensation and if there's something else going on. Remember that we said if this is less than 40, then you have a respiratory problem. If less than 40 or greater than 50, you have respiratory problems. We also want to know if there's concomitant metabolic problems. And the way we're going to do this is with the delta-delta. Okay? This delta-delta is going to tell you there's another metabolic problem going at the same time as your anion gap metabolic acidosis. So if you have an anion gap metabolic acidosis, always check both your Winter's formula and your delta-delta. I'm going to show you how to check your delta-delta. First, for your delta-delta, take your measured anion gap. Okay? Take your anion gap. Let's say your anion gap equals to, this is obviously increased, so let's say you have an anion gap of 20. You take that and you subtract 12. That's the normal anion gap. You subtract the, so let's say the anion gap minus 12, because that's the normal anion gap. In this case, it's 20 minus 12, you get 8. Next thing you do, step 2, you take this is delta number 1, delta, and you add this number to patient's bicarb. So delta plus bicarb. Let's say bicarb was, I don't know, let's say bicarb is 6. Oh, excuse me here. Go back. So I told you anion gap is 20, bicarb is 6. So we got our delta, which was 8, remember? And we got that from 20 minus 12. We got anion gap minus 12, so 8. So equals 8 plus 6 equals to 14. Okay. If this sum is equal to 24, remember that's a normal bicarb, that means there's nothing else going on. Okay. However, if this sum is less than 24, then what does that tell you? If it's less than 24, that means that what else must be going on? Why would there be less bicarb than expected? That means less bicarb, remember, in a metabolic problem means there's a metabolic acidosis. So that means there's a concomitant non-anion gap metabolic acidosis. If your delta plus bicarb is greater than 24, what does that mean? It means that not only do you have a non-anion gap metabolic acidosis, it means you have also a metabolic alkalosis. And this metabolic alkalosis is causing you to have a little bit more bicarb than you would expect. You're not going to have more bicarb than normal, but it's more bicarb than you would expect. And in this case, you already have low bicarb. It's even lower than you expect, which is why this delta is less than 24. So now you've figured out that you have both an anion gap metabolic acidosis as well as concomitant, either a non-anion gap metabolic acidosis if your delta is less than 24, concomitant metabolic alkalosis if your anion gap is greater than 24, or if it's equal to 24, that means that you have solely an anion gap metabolic acidosis. So again, let's just review everything. This is a ton of stuff I told you, and I'll show you a quick problem. Again, easy, simple, figure out acidosis versus alkalosis, step 1. Step 2, is it respiratory or is it metabolic? Step 3, if it's respiratory, is it acute or is it chronic? Step 4, for metabolic. If it's a metabolic acidosis, then you figure out the anion gap. That's going to tell you a lot. And then you're going to calculate for all your metabolic problems, you're going to calculate if there's appropriate respiratory compensation. Okay, so I'd call it step 4 or 5. Let's call it anion gap is step 4. Step 5 is the respiratory compensation. To figure out respiratory compensation, you either look at Winner's formula, or if it's a metabolic alkalosis, there's no nice formula, but you would just know that obviously it should be greater than 40, and the other thing to know, which is very low yield for step 1, but normally your body will not go over 50 to compensate. Okay, so that's how you know if there's respiratory compensation. And then you can also tell if there's also concomitant respiratory problems, because if it goes over the extremes, you have a concomitant respiratory problem. And then step 6 is whenever you have an anion gap metabolic acidosis, not only do you do Winner's formula, you also do a delta-delta. Okay, and delta-delta, you take the anion gap. How do we do this? Take the anion gap minus 12. 12 is your normal anion gap, and you take whatever that's equals to, this is your delta. Remember, delta is just difference. This is delta number. I'll call it delta 1 just to be easy. And you add this delta 1. Next step is to add delta to the bicarb, and you look at the number. If the number is what a normal bicarb is, then you're all good. And then if it's not, then you look at that. And let's do a quick problem. Let's clear this. Okay. Let me just give you some numbers. pH 7.49, CO2 48, bicarb 30, Na 135, chloride 100, K 5. What do? What is step 1, acidosis versus alkalosis. pH great above alkalosis. Now, is it metabolic or respiratory? Remember, as we look at CO2, we look at pH, both are above normal, so this is a metabolic problem. Metabolic alkalosis. Now we know we have a metabolic alkalosis, we can skip our respiratory step. We want to know if there's appropriate respiratory compensation. To do that, we have alkalosis, there's no specific formula, you just look at the CO2. CO2 is between 40 and 50, so maybe it's appropriate. And then I guess that's it for this one. So we'll do a more complicated, more useful one. So you can see that one's pretty simple. Next, pH 7.12, and you can also skip all this because I've written this all in the notes and I've done an explanation, but you can also just watch along. CO2 is 18, bicarb is 6, and then sodium is 133, chloride is 97, potassium is 6. Okay, step 1, alkalosis, acidosis. Step 1, acidosis. Is it metabolic or respiratory? We see that both this and this are decreased from normal, so it's metabolic. Metabolic acidosis. Now remember, we have a metabolic acidosis, so next step is to figure out whether there's an anion gap. So anion gap, we see 133 minus 97 minus 6 equals 2. Let's see, 103 equals to 30. So we have an anion gap of 30. Is that increased or is that normal? Remember, normal anion gap is 12, so that's an increased anion gap. So anion gap, metabolic acidosis. So now we have to figure out the next steps are 1, Winter's formula, 2, delta delta, because we have an increased anion gap, metabolic acidosis. Remember, even if you have a normal anion gap, metabolic acidosis, you still want to do Winter's formula, you just want to do the delta delta. Okay, Winter's formula. How do we figure that out? We want to know, Winter's formula tells us if there's appropriate respiratory compensation, and our formula is 1.5 times 6. We actually already did this, so plus 8 plus or minus 2 equals to 9 plus 8 plus or minus 2 equals to 17 plus or minus 2, which is equal to 18. So we have appropriate respiratory compensation here. Finally, we're going to do a delta delta. Anion gap we said was 30 minus, how do we do this? Delta delta minus 12 equals to 18. Next step, what do? Next step is you add bicarb. What is our bicarb? Bicarb is 6 plus 6 equals to 24. And we see here that, what does this mean? This means that you have a pure anion gap metabolic acidosis with appropriate respiratory compensation. When we figure that out from Winter's formula, but there's nothing else going on because our delta delta is 24. It's not below 24. It's not above 24, and so that's how we approach a problem. Because you can see if you follow these 6 steps, it's actually very easy. Okay, there's more practice problems in the notes. This is a little bit lower yield for step 1, but very useful to know. All right.